Hello viewers, I'm here again. My name is Adeka Solomon. Welcome to Adeka Mathematical Solutions. Today we'll be dealing with probability, and I said a probability of an event E is therefore a number which satisfies this. That is 0 is less than or equals to probability of that event less than equals to 1. That means the probability of that event lies between 0 and 1. So without taking much of your time, I'll move straight to the examples so that to explain this. And in this very video, I focus more on the tools examples on the tools of a coin. So please, before you continue, don't forget to subscribe to my YouTube channel, Adeka Mathematical Solutions. Share my videos. Follow me on Facebook and Instagram. Thank you as you watch. So in the example now, I says examples. In a single throw of a fair coin, find the probability that A head appears, B a tail appears. So as a solution, this is the solution, and we say this A. Let S be the sample space, be the sample space. Then okay, so we are going to bring the sample space out of a throw of a coin. If you throw a coin, then the sample space will be equals to, when you throw a single coin, either a head will appear or a tail. That is the sample space. We have two events here. Either a tail appears or a head will appear. So in this example, the example says the probability that the first one, the head appears, but here now we can say the number of the sample space now is equals to 2. Okay, so for the invent one, which the head will appear, the invent one which says the head will appear, now will be, that is, this one is for the head, now will be equals to the number of the events 1, that is n of events 1, which is equals to 1. So here now the probability, since we have the sample space here, now the probability of the head appearing now is n of event 1 is all over the number of the sample space, which is equals to 1 all over 2. We have 2 here, so the sample space is 2. So the B part, says the B part now says a tail appears. So since we know the sample space to be 2, and let's say for the event 2 now will be equals to, for the tail, and here will be n of event 2, number of events 2, which is the same thing as 1, because we have one tail here, one head here, one tail here. So the probability of this now, will be equals to n of event 2 all over the that is the sample space, which is equals to 1 all over 2. So that is that. So let's move to another example. Okay, in this example now, example say in a single throw of two fair coins, find the probability that A A says two heads appear. B B says two tails appear, and C says one head, one tail appear. So let's move to solution. But before we continue with this example, let me give you a logic. Since we are dealing with a coin and a coin has only two sides, the head and the tail, if you are given a probability of it for you to get a sample space, the simple logic is for you to say 2 raised to the power of n. N is the number of times it's thrown. That is the number of times it's being thrown. Like in the first example, it says a throw of coin once, a single throw of a fair coin. So that is 2 raised to the power of 1. Your n now is 1 and 2 raised to the power of 1. So your sample space will be 2. Like here now is the sample space. Okay, to get your n of sample space is 2 raised to the power of n. So in this very example, we said in a throw of two fair coins. So here now, since it's two fair coins, it's 2 raised to the power of 2. Our n is 2. So now our sample space will be 4. So if a fair coin is being tossed, it's being thrown maybe 6 times, it will be 2 raised to the power of 6 and you get your sample space. Okay? So let's move to the solution for this example. I will say um let else be the sample space. Okay, so our S now, since it's a coin being thrown once, to generate the twice, let's generate the sample space. In the first sample space, we say that when a when a coin is thrown once, you have a sample space once, you have a sample space to be head and tail. Okay, so if the sample space is being thrown and you have a head and a tail, if you have another head and tail again, so the probability, the sample space now will become this and this will be head, head, that is this and this will be head, head. Okay, this and this will be head, tail. This and this will be tail, head. This and this will be tail, tail. Okay, so that is how to generate a sample space, and I will teach you when you have three, or when you throw a coin 3 times. I will still show you how to generate that in our next example. So from here, the example say fine. So here now we have a sample space of 1, 2, 3, 4. That is 2 raised to the power of 2 is 4. Okay. So our sample space, n of sample space, now we have to be 4. Sample space is equals to 4. Okay. So our A part now says 2 heads appear. So when it comes to this sample space, you will see where the 2 heads appear is this. It's only once. So 2 heads appear. The probability, the event of two heads will be equals to 1 all over 4, because the sample space is 1, 2, 3, 4, and 2 hairs appear only once, so it's 1 over 4. Okay, and the B part says the probability that is two tails appear, and if you see where the two tails appear is only once, so here now it will be the end of two tails will be equals to 1 over 4. Okay, and the other one says one head and one tail. So the C part now says the probability of one head and one tail will be equals to, since we have one head, one tail, one head, one tail, two places, it will be 2 over 4, and 2 over 4 is equals to 1 over 2. So this is the example, and we'll move to more examples to explain to you to understand it well. Okay, example 3 says in a single throw of 3 fair coins, find the probability that one head, two tails appears, B, two heads, one tail appears, C, at least one head appears, D, no head appears. Okay, but when you look at our example here, which we solved, we know that the probability of when you throw a single coin, two fair coins, you generate this sample space. Okay, and when you do, you have the probability of two heads, you have 1 over 4, probability of two tails, you have 1 over 4, and probability of one head, one tail, you have this. Okay, so now we are moving to a single throw of 3 fair coins. So solution, and if you remember, I told you to get a sample space, n of s will be equals to 2 raised to the power of n. And since it's been thrown 3 times, our sample space will be 2 raised to the power of 3, and 2 raised to the power of 3 is equals to 8. So this will help you to generate the sample space correctly. So without taking much of your time, let S be the sample space. Okay, so our A, probability of event 1 will be equals to, okay, let's generate, before we continue, let's generate the sample space. And in a throw of two, in a single throw of 2 fair coins, we have the sample space to be head, 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 tail, tail, head, and tail, tail. This, for the single throw of 2 fair coins, you generate this as our sample space. But in a single throw of 3 fair coins, that means you are going to add another sample space of the 1. And when you throw the 1, it will have head and tail. When you throw 2, you do. So when you multiply this, you will generate for the 3. So let's generate for this, and we say h multiplied by h, That is head multiplied by head. You will have head, head, head. That this and this, you have three heads. And this, we have this and this, we have head, head, tail. This and this, we have head, tail, head. Am I making sense? And this, we have head, tail, tail. Okay, let's move. This and this, we have oh, this and this, we have tail, head, head. This and this, we have tail, head, tail. This and this, we have tail, tail, head. This and this, we have tail, tail, tail. So this is our sample space, and which is equals to 8. That is 1, 2, 3, 4, 5, 6, 7, 8, which is equals to 8. Okay, so our A part says probability of event 1, which the event 1 now says one head, two tails appears. So for you to get the answer, you come here, look for where the one head and two tails appear. And if you look at this, we have three heads, two heads, two heads. So here we have one. Here we have one head and two tails. Here we have one head and two tails. And here we have one head and two tails. So the probability now is 1, 2, 3. Is 3, and our sample space is 8. Is 3 over 8. Okay, let's move to the B part. The B part now, the probability of event 2 is equals to, the B part now says 2 hairs, 1 tail appears. So the probability of 2 hairs, 1 tails appear. We come here now, 2 hairs, 1 tail appear. Mark it differently so that it will not confuse you. 2 hairs, 1 tail, 2 hairs, 1 tail, 2 hairs, 1 tail, and you have 1, 2, 3, which is 3 over 8, which is the sample space. And okay, the C part, now says at least one head, at least. C now says at least one head appears. So when it comes to the sample space, they say at least one head appears. So anywhere the head appear, we are counting. At least, but there must be a head in an event. So if you look at this one, no head appear. So the probability that at least one head appear is 1, 2, because we have head there, half head there, half head there. We have 2 heads there, we have head there, we have head, 2 heads, 2 heads, 3 heads. But the probability that at least one head appear is 1, 2, 3, 4, 5, 6, 7, because we have so the probability of event 3 now will be equals to 7 over 8, because 1, 2, 3, 4, 5, 6, 7. So it will be 7 over 8. And the D part says no head appears. Okay? If you look at this, the probability that no head appears, probability of no heads appear. If you look at the sample space, the probability of no head appears is only here. No head appears here. So its probability of events for which no head appears will be equals to 1 over 8. The sample space is 8 because here they say no heads, so it's only here that no heads appear. So this is about probability. In our next video concerning probability, we'll be dealing with when you roll or when you toss a die, the result, the outcome, like that. Don't forget to subscribe to my YouTube channel, Adeka Mathematical Solutions. Follow me on Facebook, Instagram, share my videos. Thank you for watching. Thank you. Bye.